Good morning, all of you. Welcome on my YouTube channel. So today, the topic which is we are going to discuss that is BGP path attributes. Okay. So we have 12 type of path attributes inside of BGP, and all the kind of manipulations according to the paths and best path selection criterias is also depend upon these path attributes. Okay, so we are going to discuss the detailed information about the path attributes, like what is the use of next hop, what is the use of multi-exist dexist, okay, what is the use of local preference, aggregator, communities, okay. So each and every path attributes we are going to discuss by today in this class, and after doing discuss these things, we will also try to perform some practical part of that as well. Okay, so yeah, so let me just quickly connect. Guys, am I audible?
यहाँ से बना लेते
Okay, fine. So let's discuss then the path attributes which is we did not complete from yesterday. Okay, so what we are going to do,
हैं
we are, yeah.
Jay,
Hey,
good morning.
very good
Sorry,
morning. Yeah,
disturbing you.
tell me what happened.
Uh, I my VM license is saying the license has expired. You must have the valid license to power on the virtual machines.
Okay, like you need the virtual machine. I think VMware expired,
The,
right?
yes, the RDP machines.
IDP machine. Can you just share your screen and show me exactly what's the problem you're getting? Stop sharing my screen. Yeah, you can.
Your license has expired. You must have valid license to power on the virtual machines.
No, what I'm talking about, like, are you able to take the access of RDP, or are you not able to take the access of RDP?
No, I have already taken the RDP. While opening this GNS3,
Okay, fine.
uh,
Hmm.
I opened the virtual machine. Then I found that not able to add any device, and then I go to virtual machine and found that this is not powering on. It's saying that your license has been expired.
Okay, so I think your license key is expired on your GNS. Sorry, your VMware. I hope so,
Yes,
because of it's been one month.
VMware.
I think. Can you just share your screen and show me exactly what is the problem you're getting inside of it?
Okay, okay. Are you able to see?
Yeah, it's visible for me.
Okay. So while powering on,
Mm-hmm. Any of the machine you can, or just turn it on GNS VM. I think you have paused that machine.
um,
You have paused that machine on the GNS on your VMware.
I'm also facing the same issue. Maybe it's for all.
Just turn on the first of all the virtual machine from the GNS3 VM. Are you getting that? Not this
Yes,
one,
yes.
not this one. GNS3 VM. You have to
The same
open
same
that.
error only there.
Okay,
The
just
same.
try to do one more thing. Just close this application once and try to open once again. That both the application you have to close it. GNS3 and GNS3 VM where you're imported on your VMware. Okay, so turn off all the machines from the GNS your VMware. Sorry, okay, and try
I
to
tried
turn
two
it on
times, but
once
again
again. Yeah,
I
click
s-
on exit. Mm-mm. Okay, okay, got it, got it. One more thing. See, just open your VMware. Let me show you what is the error you're getting. Just open your VMware. Just minimize this. Your VMware license has expired. Okay.
yes, that is what
Got it,
that is
got
what
it,
I wanted to say.
got it, got it.
I think we must have your evaluation
Okay.
period has ended. The
What
valid
I'm
license
what
is
I'm
going to
what I'm
follow.
going to do. What I'm going to do. Just click on enter a license key. Click on enter a license key. Go on with VMware and click on enter a license key. And I'm putting your the license key inside the chat box. Just give me a minute.
Okay.
Or I can just share it to you on your WhatsApp. Okay, so directly you can go and try to copy paste from there. Okay, let me just. Okay, and because of I buy this VMware Workstation Pro, so I have all the license. Yeah, now you can check your WhatsApp, and let me just first of all share my screen and show you exactly what is that. So here is the license key. You have to open, but any of the license key you have to copy. Would be like this or any kind of that. Okay. Yes, so you have three license key. You can try any of that from here, and you can paste it inside the internal license key. So you will not face any problem after that. If you will still facing the problem, then you have to uninstall the particular application, and I will upload this on your Google Drive, and I will share it to you. Okay.
Can you share the key in chat in WebEx?
Yeah, in WebEx. Let me just.
Now it's working.
I know that.
Since yesterday I tried two or three times. It did not happen,
I know
then I
that.
left
I
it
know
with.
that. When
Okay,
I
we'll discuss
saw
on
that
tomorrow.
particular error, so I realized that that's the problem because of whenever your batch was started. So it's been near about 1 month. So the trial period has expired, right? Not an issue. Yeah. So let's discuss basically what are the new topics are the points which is we have over here. Okay. So we have done the few names of the path attributes from yesterday, right? So what we are going to do first of all over here, we are going to discuss the path attributes because of we have the two types of path attributes that is we call well known and optional, or you can say that manual. Okay. So inside the well known we have mandatory and discriminatory two types of path attributes inside of it. Then inside of manual, we have two types of path attributes that is transitive and non-transitive. Okay. So what is the well-known mandatory and what is a well-known mandatory path attributes which is we have? So BGP will always carry these attributes with BGP update automatically. So whenever you will send a BGP update message, right? So what is that? What is the use of BGP update message? What are the content it's here? Let me show you. See, it will share the prefix information path attributes, right? Because of see all the kind of path attributes is gonna to share inside of your update message, right? So whatever the path attributes you are going to use, all the kind of information who is going to carry that update message. Okay, so don't be confused in that because of if some interviewer will ask like which message will carry all the kind of path attributes information, so always you have to say that is update message because of inside of your update message all the kind of path attributes selection criteria and is going to share to select the best path from source to destination. Okay, so whatever the path manipulation we will do, that's totally depend upon your update messages. Okay, and inside of your update messages lots of things is also going to share that would be like network layer reachability information from source to destination, how much hop away we have, right? And if any router have multiple prefixes and all the kind of attributes are the same on the router, so then it will just find it out kind of your uh, your path attributes. Okay, so simultaneously one by one it will check all the kind of path attributes to select the best path if it is getting the same the same the any kind of prefix from the same route, or you can say that the directly connected neighbor. Okay, from the two side, let me just draw a scenario. Would be like Okay, so if this one wants to share or anyone, if anyone is sharing any kind of prefix or any messages inside the update message or any kind of thing, so what it will do, how it will select the best path, that which one we have to make our best. Sorry. So in this case, what it will do, it will check the whole criterias which is we have simultaneously. Okay, so whatever the criterias we have about the path attributes, it will check it and then it will select the best path to reach destination. Okay, so what are that, we will also discuss that as well, like if you are getting the both the side of this prefix, so how you can basically utilize this kind of uh, path attributes inside of it. Okay, so then we have well known as well. Okay, that is we call this one well known discriminatory. Previously it was mediatory. So these path attributes, who will who will uh, who will carry these information of these path attributes inside your update message automatically. Okay, so automatically it will just share these information inside your what, inside the update message. Okay, now after that we have well known discriminatory. So what is the use of this path attributes? Sometimes Bgp will carry these attributes with Bgp update, sometimes it not. It depends upon neighbor, right? It depends upon neighbor. It is IGP neighbor or ABGP neighbor. So basically, what is happening, like suppose that the same thing also we have from the same side, and suppose that I'm using the 100 AS number on this, 200 AS number on this, and 100 AS number on this. So they will share their own prefixes, right? And they will, it will just get this some kind of prefixes which is coming from that, that is then it will understand. Okay, whatever the prefix I'm getting it, between this I have the EBGP neighborship, and between that I have IBGP neighborship. So these information who will carry, sometimes, see, sometimes this information is going to share using your update messages. Okay, means in case, in case update message, matlab means some cases your update message will carry these discriminatory well-known path attributes inside of it. Okay, and it is this this path attribute is also used to identify, like what, this path attributes, this well-known path attributes is also used to identify, like between the two BGP peer, which type of neighborship we have, like we have EBGP neighborship or IBGP neighborship. Got my point? So then it will, sometimes it will just make that information inside the update message and then it will share it with the others, but sometimes it will not, right? So it depends upon your which type of neighborship you formed. Okay, now then we have optional transitive, that is this. Okay, so inside of it, this we have aggregator and communities. Okay, so what is that? If any BGP neighbor receive any update with the optional transitive attributes and that route doesn't support that attributes, in that case it will not drop update. It will accept that update and also will forward it to the another neighbor after removing that attribute. So what it will do, see, if suppose that in the optional attributes, let me take the same scenario for that as well. So suppose that AS number 100 I'm using over here, and this kind of AS number I'm using for the BGP. So what will happen if any BGP neighbor receive any update message? Suppose that they are exchanging their update messages. Suppose that there is some prefix would be like 1.1.1.1, and they are exchanging this prefix inside of your BGP with using network command. Just hold on a second. बहुत डेटा का हुआ काम करो तो शाम को करना पता चला इसी में डेटा चला रिपोर्ट मारने को खत्म इतना तेजी से हो रहा है ना मेरा जो 4 GB वाला प्लान था वो तो खत्म हो गया देखो 3.86 बहुत हमारा इसमें बहुत कुछ चार्ज ये देखिए कह रहा हूँ ट्रेनिंग थोड़ा थोड़ा समझे तो sorry so yeah so inside your basically where were we yeah so we have we were on the optional transitive right so if any prefix advertised inside the bgp using network command so what will happen this will share this information with us right means uh, with this both the routers okay and this information is what if any BGP neighbor receive any update with the optional transitive attributes because of we are advertising the some prefix using manually we are advertising that okay and that router doesn't support that attribute in this case suppose that any of the router suppose that this router is not supporting this kind of um, this kind of any kind of like aggregator or a kind of your communities because of the some communities would be having the some kind of large securities right so sometimes the if some router is not supporting so in this case what will happen it will not drop update because of the all the kind of network because of I have advertised this prefix using network command so where you will get inside the update message because of update message will carry all the kind of information right and this will give you the update and then the other will give you the acknowledgement or the reply whatever it is okay it will not it will not basically deny that particular update message it will accept the update okay whatever the update it is getting it from here it will update it will accept the update message okay it will accept the update message it will not deny that might be the some information would be important for us so what it can do it will accept the update message but that update and also will forward to another neighbor after removing that attributes because of if the some attributes is not supported as we have like suppose that I'm sending some kind of communities in that so suppose that sometimes some communities is not going to support on the some routers in this some cases of that bgp so what will happen uh, this will accept the update message and it will share it with the other neighbors as well this other neighbor who is that which is this router this will share it but after removing the attribute because of might be that attribute can be harm on this device as well okay so we must have to secure our all the kind of bgp network if you remember before a few months ago our all the kind of whatsapp facebook and all kind of instagram and all the was down right so what happened actually there was some attributes which is using we were using in that and due to some attributes the whole bgp neighborship was goes down okay so that was the main problem like some cases in the some cases the sub attributes some routers doesn't support so in this case what it can do it can it will remove that particular attribute and then it will share it with the kind of your neighbor but the IT team was thinking that might be that attribute would be important right whatever the encryption attributes it is getting it from the router number this might be that attribute is important so what it can do it is accepted because of it will just see that particular attribute which is coming from the optional non-transitive path attributes okay and it will accept because of it is getting the using your update message so I think then the IT teams just think about like might be whatever attribute I'm getting it inside your update message so might be this is important for me so this will accept and this without removing that particular attribute without removing that particular attribute is just shared with this your home offices and all, right? So that's the exactly happened. And yeah, so that's the exactly happened, and that is why the whole network was down, right? Did you get my point in this, or should I have to repeat it once again?
No, it's fine for me.
Okay, so that's exactly happened in that
Yeah, and what
particular
time?
case. Yeah, tell me what happened. Any
Yeah, I
doubt?
do not
Okay,
understand.
okay, fine, fine. Okay, then let's discuss the next attributes which is we have, that is optional non-transitive. So inside the optional non-transitive we have multi-exit discriminator, we have originator id, then we have cluster list. So what is that optional non-transitive attribute? What is the use of that? If any bgp neighbor receive any update with optional non-transitive attributes and that route doesn't support that attribute, in this case it will discard that incoming update. Just like the same scenario, if I'll take it over here, see, inside the optional transitive, what was happening? It, it was accepting the update message which is coming from the AS number 200. This is AS number 100. Then this is AS number 200. Inside your what? Inside your optional transitive attributes, it was accepting that, but the update message, whatever the update message it is getting from the optional, it was accepting, but it is going to remove the particular attribute from there and then it will share it, right after removing.
Sorry,
Yeah,
sorry. What kind of attributes it will be like that? It's something that related with your route preference, local preference, or
see,
we are the administrator setting something that is being triggered from the initial router to destination router. Actually, I would like. I did not understand what kind of this optional transitive message is are.
see, we have two types of routers, that is provider edge and customer edge. Okay, so this router is suppose that your provider edge, which is coming with your ebgp neighbor, right? And this is your customer edge where your ibgp is gonna be work, right? And inside of this your mpls and other protocols are all also working inside of it. Okay, and we will, when your doubt, this doubt will be clear whenever we will cover the attributes over here, like what is the use of next hope, what is the use of your med, what is the use of multi-exit discriminator, and whatever the things, then your doubt will be clear regarding that. Because of, see, we know that the some prefixes are getting it using your non-transitive attributes, and they are getting it inside your update message, and then it is going to remove the particular attribute from there, and then it will just share it inside your customer edge, right? But exactly what are the what are
Okay.
the particular information which is it's going to share? That can be anything, that can be your password, that can be your like neighbor information, that can be your like the some kind of big data and all. Okay, and that can be your different protocol as well, which is running on your provider edge. Because of, we don't know that how many kind of routing protocols and the kind of protocols are working on the provider edge. Because of, we know that there is a kind of lots of like lots of networks are working over there beside of the ISP. So we don't have any kind of information for that. But whatever the things we will get, we will have to divide the particular information inside of your transitive and non-transitive, and then we can get it inside of your customer edge. Got my point?
Got it. It is
Yeah,
all depend upon this external factors.
yeah. So
Uh, yes,
okay,
yes.
fine.
Okay.
So let's discuss. See, in your optional transitive attributes, what was happening? It was accepting that, but inside the non-transitive, it is not going to accept either. It is getting it from the update message or whatever. Okay, whatever the attribute is, it is getting it from the update message inside your update message. It will not accept. Okay, it will simply discard the particular message from there. Okay, now your path attributes are here. Okay, So what is next hope? That is we call reachability. Okay, next hope reachability. If next hope not reachable, then it will not compare other path attributes. If any router receive any prefixes from the two neighbor and next hop is reachable via both router and BGP will not define best path based on the next hop. Okay, suppose that, let's take the same scenario. Okay, here is the 200, 100 and 100. Okay, now next hop is what, like if the some kind of, if you did not make a neighborship, that is EBGP neighborship or IBGP neighborship inside of it, and then in this case what will happen, our next hop will be not reachable because of the VGP will not define the best path on this based on the next hop. Okay, why? Because of there is kind of like the neighbor is not receiving any kind of prefix, right? The neighbor, our neighbor is not receiving any kind of prefixes. So in this case, what will happen? The next hop always see from the here. Suppose that now I just make the neighborship from here with between these both the things, and we know that with the reachability on the next hop, which is we have only one hop away. How much? Only one hop away from the both the side. So it will get confused like which one we have to select the best path because of the next hop is what? The next hop is only one. We have only one hop away. So in this case, this will get confused. So what will happen? Then it will just move to the next criteria, that is we have, that is weight. Okay, so the weight is your Cisco proprietary and also it has locally significance. Okay, means whatever the Cisco routers and the Cisco devices you are using on the BGP, this weight will work only and only on that. BGP will not carry weight information with BGP update. Okay. Now, how it will share? For self-advertised prefix, it is by default 32768. Okay. So like multiple prefix, whatever the prefixes you can share it, that is 32768. Okay. By default, this is 32768. And all received prefixes by default is zero because of we are not receiving any other prefixes over here because of only one hop away we have, and we have just only what, directly connected neighbors. Okay, higher weight will be always preferred. So you can just manipulate the weight using the some command, that is you have to go inside the BGP. Okay, and then you have to go inside the you have to create the first of all route map. Okay, and then you can give it the weight over here. Okay, whatever the spelling we have, you can just make it. Okay, wait, and then you can just make it that. And always your higher weight will be preferred, like if ever, if any things we are going to purchase, so always what we have to do, like we have to check the particular things which would be regarding which like if I'm going to purchase any car or any bike from that, so I will sorry, I will basically check the on the kind of mileage, stabilities and all the things for that, right? So in the same cases we will also check this kind of weight as well, like what is the mileage it can give, right? And always the higher mileage will be preferred for that. Okay, now let's move to the next criteria, that is local preference. So BGP will always include local preference attributes in its outgoing BGP update, but only for IBGP neighbor. So what is the local preference which is we can use it? Suppose that the same network, I can take it. So for the best selection criteria, this will also get confused because of it knows that where I have to send that. Basically, it only support the internal prefixes. Okay, so if any internal prefixes is coming from here, because of we have the IBGP neighborship from here, so it will make it as a best, right? If suppose that if I have the AS number 200 over here as well, and they just make the or 300 AS number, you can say that, So what will happen? This will get confused because of from the both the side we are getting prefixes as a EBGP neighbor, but this local preference only support IBGP, right? Got it? So in this case, this will get confused, and then it will move to the next criteria, which would be self-advertise. So self-advertise prefix will be preferred if router receive same
So Jay,
prefixes.
can you come? Sorry,
Yeah,
sorry, Jay. Jay, can you come with the local preference once again?
yeah.
Small.
See,
So in the local preference
mhm,
activity in IBGP only, is IGP or EBGP? It's IBGP only, right?
IBGP. Always your higher
Okay.
neighbor will be preferred, right?
Okay, okay.
By default local preference is what 100 for internal prefixes, right? And higher will always preferred. You did you see that higher will be always preferred. So if you want to check like if you want to make it as a best, so what we have to do, we have to make changes inside the local preference where we can do in the same thing, like you have to go inside the BGP and then you have to like you can directly go in the route map where you have created some kind of map, and then you can just give it what local preference, 110 you can give it, or 101 you can give it. So this will prefer the higher local preference for the kind of sending information from source to destination. Okay, we will also discuss because of I have the all the
Uh,
kind, yeah.
Regarding on the for weight, we will use as a IBGP or EBGP for that also IBGP
Where is
for
that?
weight attribute.
See, for the weight, we have to use always the higher weight will be preferred, right? And this will not carry any weight information with the BGP update, right? And this is your locally significant. That means your it will works inside your IBGP neighbor. Okay, but let's suppose if I have the basically EBGP over here, EBGP neighborship, so this will not get any kind of things. Okay,
Okay.
so then it will what it will do, it will just move to the next criteria, that is local preference. So in the same
Okay.
local preference we are checking the only internal prefixes. We will only prefer the internal prefixes attributes, but if I'm not getting any internal prefixes because of all the kind of EBGP neighborship which is I have made it, it's not coming inside the EBGP IBGP neighbor, right? So in this case this will also discard that particular things. So what will happen, yeah.
Jay,
Yes, yes.
Jay, sorry for disturbing you again. I
Voice is breaking.
I think as per my understanding,
Yeah.
these mandatory attributes is only valid for the IBGP concept, right?
Yes.
Yeah, so we can consider that this since we will manipulate for the IBGP neighbors only.
Yes. Correct.
Okay, okay.
Okay. Okay. So let's discuss the self-advertised, which is we have fourth number of the path attributes over here. So what is that? See, I'm not advertising as a self on this kind of things because of we know that either we have the EBGP neighborship inside of that, right? So what I'm going doing it like from the both the side, I'm advertising the some prefixes would be like any kind of prefix can be happen, right? But this will receive it as a EBGP neighbor, right? This will receive as a this prefix as a EBGP neighbor. So what will happen if router receive the same prefixes from the different neighbor, then it will not compare self-advertised because of always it just compare as a self-advertised, which is this one advertised inside of that IBGP. Because of this is the self-advertised local this path attributes is made for the IBGP prefixes. Okay, so here is our EBGP is working. Suppose that, so in this case, what will happen? Your it's not getting any kind of things, so it will just deny that particular self-advertised path attributes from here as well. Okay, Now then we have the AS path. Okay, so what is the use of this AS path attribute? So AS path list can have maximum 64 ASs, right? So in a single ASS path, we have 64 ASS routes to define that particular path, like which one is the best to provide the network after crossing the less number of years. Okay, so but how it can get it, because of we know that we have just only to reach from the anywhere we can, how we can make it as a best we don't know, because of between that we have just only ebgp neighborship, and this is one hop away, means only one as or two as number is running between this, right? Like ebgp neighbor is what, like between the two as number is running the particular neighborship. So what will happen, this will also deny the particular as path over here, because of it will see that the all the kind of maximum years it support, that is 64. I know that that's fine, but whatever the basically path which is best, I have to find it out. I am not able to find it out from here. Okay, give me a minute. Okay, fine. So let's discuss then the origin code. Okay. So inside the origin code, how you can define the basically what is the redistributed network, or what kind of bgp network which is we have. So we have the origin code which is gonna be identified with IE question mark and this, right? So I means what, if we are advertising routes in bgp with network command, so that particular prefix you will get it as a I, right? Let me do one thing. I think we have done that from yesterday, right? But let me check it. Let me do it from here. So you will you will. I show you exactly what is happening. Okay, let me turn on the COVID Pro Max, and I'm basically going to show you exactly what are kind of things which is we have. Okay, just give me a minute. I'll show you exactly what does the use of your IE and this kind of things. Okay, so I'll just take the access of one of the IBGP router, sorry EBGP router, 43204, right? 43 192.168. Okay, so what I'm going to do, I'm going to take the access of router number 20 and 21. So I'll show you exactly the some kind of route map, and this one as well. I will take the access. So let me directly take the access of this 21 and 20, 20 21, 20 22, 21, and this 22. Okay, okay, fine. So let me take the access of first of all this 20 number router. Okay, sorry, not this. 22. See, do show IP route. It's not coming. I think the BGP neighborship is down right now because of we did not turn on this router, right? So we have to turn on that as well, because of, if we do not turn it on, so how you can get it, the membership comes up, right? So let me turn it on, and let me turn it on the this connected one as well. Okay, the so router number 7 and 4. Okay, let me just turn on quickly router number 7, 4 and 7. Okay, let me take the access now. It will take a bit of time, so I think it will take time for turning on all the kind of membership process done. Do show IP route. See, are you able to see that particular thing? The memberships is coming up. It will take a few minutes only. Okay, let me show you. See, the membership is coming up. It will take might be the few seconds for that. Or I can do one thing. I can just advertise the particular things from there. See, you will get it. I that is from the internal and all. I think we have discussed that, right? Valid and best path. You will get it would be like this, right? And I, which is that means you will get that particular prefix which is coming from the internal, right? Uh, IP interface brief. Let me check the particular any kind of, if we have the loop back, that would be interface loop back one. And okay, so let me advertise that loop back. So show run interface loop back what, loop back 0, right? So let me advertise this network. Okay, so in which, in your BGP, so do show run by section BGP. So let me show you exactly which BGPS number is running. That is this, and use that particular things using network command. Okay, which prefix we have to advertise, that is this one, right? And give it the mask. I think I just forgot it. Mask. Okay. Now let me show you show IPBGP. See, now you are getting as a best and locally, right? If I'll show you IP route, so you'll get the particular loop back as well. Where is that loop back interface? 10 network 10.1.0.12, right? So 10.1.0.12 you are getting it as a 32 is directly connected on loop back 0. So if we have any other loop back on the router number 22, so we can advertise that on as well. Do show IP interface brief. Okay, we do also have, so in which BGP AS number is running over here, that is router BGP 65002. Okay, and then use the network command, that is this, and then mask. So mask would be always your slash 32 value. Okay, show you the particular route, which is this network is coming via which, this is the 22, this is the network. Dot one is that, what is that, dot one is here, and this is coming from what, this is coming from B, that means this is coming from BGP, right? That means whatever the network I have advertised using the network command, now I'm start getting that particular network inside of that. Okay, are you getting this B? That means which is these prefixes is coming from the BGP, that is 10.1.12, 112, and 212, right? So this is coming from what? You will get the what? This is
20.
yeah,
20 is also from the
AD value,
BGP.
right? So you'll get the particular prefixes from there as well. Okay. Now, if I'm talk about so IPBGP summary, let me show you that as well. Do show IPBGP summary. So inside of this summary, what is that? You will check the particular state as well. Right now, all the kind of routes is stuck inside the ideal state, as you can see, right? What are the state we have, guys? We have done it. Let me just tell me what are the state we have. Idle. What?
Idle. It will
Yes.
connect active, open send, open confirm established.
Yes. So right now it's stuck inside your idle state. That means the some interfaces has been not advertised inside the OSPF because of, see, when the neighborship will come up, whenever you will advertise these prefixes inside the internal areas, right? So if your internal areas will be working properly, so they will exchange their neighbors, right, with us, with which, with your router number 22. So might be your some kind of things is not gonna be work on this router number 22, that the some interface internal protocols are not working properly. That means might be your OSPF problem can be your pen, right? So IP OSPF interface brief, if I'll show you, there is no kind of loopback interface you can see over here. And there is one more thing, that is cost. Okay, now how you can change the cost on the interfaces, that is, here is that how you can change it. Which interface I'm using? Interface Ethernet 0/2 IP OSPF cost. Which cost? The default cost, which is 10. Right? What is the default cost, guys? On the physical interfaces, that is Ethernet. That is 10, right?
Yes.
Sorry. So we
Right,
can
right.
change the cost, and which interface we do also have to advertise, that is loopback 0. In which IP OSPF 1 area, which area 0. Okay, so I have advertised that prefixes inside the area 0. Let me just check the interfaces first. IP interface. Okay, is it loopback 1 0, right? So interface loopback 0, and which OSPF AS is running over here. Let me show you. Process ID 1 and area 0. So let's advertise IP OSPF 1 area, and we sometimes we have to clear IP OSPF what process, right? If you have remember how you can clear that process, clear IP OSPF process. Okay, you have to click on yes. Okay, then it will clear all the kind of OSPF process. Might be the some problem would be on your this switch as well, because of all the switches is not turned on, because of all the devices is not turned on. So whenever the all the devices will comes up, then it will start sharing their prefixes, because of all the
And
devices right now in the down, right? As you
say
yeah.
one small doubt in production device while clearing this kind of OSP, any fluctuations might happen or
See the fluctuation if I'm talk about, so yeah, the first of all neighborship will broken down, and then the
okay,
neighborship will come up, okay, of the OSPF neighborship.
okay.
Okay. Okay, right now all the switches are worked. I think these switches are not working. Might be the some problem inside your the iOS problem can be happened. So might be that's the problem. Okay. Otherwise, we will get all the kind of access. Let me just take it from here. Let me try. Yeah, it's working properly. Fine. Let me try that as well. Okay. Now, if you can, if I'll show you on the router number 22, so you can see whenever I just turn on all the devices, then the membership is coming up simultaneously, right? If I'll show you now, that is show IP route. So you will get what? You will get the multiple BGP prefixes which is coming here, right? See, these are the BGP prefixes, as you can see, right? That means previously all the routes was down. So that's why we are getting the 4 5 prefixes of the BGP And when the we just turn on the routes, then you can see over here that lots of the OSPF and BGP prefixes we are getting it, EBGP and OSPF prefixes. What is that? Check the AS number, the AD value, sorry. Okay, so what is that? This is OSPF, this is EBGP, correct?
Mhm.
And then we have IBGP neighborship as well. You can see here. Okay, this is what, this is IBGP neighborship. Okay, so we have lots of things. Just give me a minute. Am I audible?
Yes.
Okay. Still the membership is coming up, right? So let it be. Okay, so let's jump to the part of your path attributes. So we were on the origin code, right? I think we are missing some things on your router number 22, right? 21. Let me take the access and so I'll show you. What is that? What is happening? 21. That's already open. Not working, but let it be. This is the kind of things which is you can do, right? So let it be. Let me turn off all the devices. And yeah. Okay. So let's come to the part of your med. So what is the use of med over here? So by default, mid is 0, and always your lower mid will be prefer. Okay. If we redistributed any routing protocol into the BGP, the metric will go along with the BGP update in the form of med. Okay, like suppose that the BGP is running inside of this area, and this router is participating in OSPF and BGP as well. Okay, so what we do, we perform redistribution between that, right? So whenever these prefixes will comes inside the BGP using redistribution, so you will get it as a form of mid. Okay, multi-exit discriminator. Okay, now how you can get inside the BGP using your update message, because of inside the update message this update message will carry all the kind of your like path attributes informations, right? So this will carry all the kind of things inside of it. Sometimes metric will be zero, sometimes null. Okay, so we must have to check it. Sometimes zero or sometimes null, that means like zero means zero, null means zero. That means the same word, it can use it. It is used over here, but yeah, you can just see that kind of things now. But there will be nothing kind of like whatever we have the scenario, we are not redistributing any kind of things, right? Just only EBGP neighborship we have. What we have? Just only EBGP neighborship we have. So what is the use of then made over here? Nothing any use. Okay. Then what it will check? That is this. It will check the external over internal. Okay. Now, if any prefix coming from to different neighbor, one is EBGP and one is IBGP, then it will prefer external first. Okay, what it will prefer? External first. But what we have just only EBGP neighborship. What we have? Just EBGP neighborship. That means we cannot check this kind of things for that as well. But what is the use of it? If it is, we have the some kind of internal one side and we have some kind of internal over here. So what it will do? It will just deny that one. It will make it this external prefix as a best. The external neighborship. You can say that EBGP neighborship because of, see, the EBGP neighbor having the lower AD value. Okay, so keep remember in your mind, always lower AD value will be preferred first. Okay, so inside the external over internal, always your lower AD value will be preferred. See, what is the AD value of IBGP? That is what, 200, right? And what is the AD value of EBGP? That is 20. So what is that? That means it is preferring the lower AD value for that, right? So in a simple terms, you can identify that particular things from here. Okay, but what we have, just give me a minute, guys. हेलो. जी सर. सर कल की मैंने अटेंड की थी, आज का आई थिंक मेरे को पता नहीं, मैंने पूछा भी था मीटिंग में. ओके ओके, हाँ हाँ, आ गया सर, अभी जस्ट आया है, 1 बज के 2 मिनट अभी जस्ट हुए, मैं करता हूँ ज्वाइन. ओके ओके सर. ओके, जस्ट वेट अ मिनट. Give me 1 minute, guys. Okay, I'll just be back to you. Lots of meetings are working over here. What should I do?
Okay, then let's start. So our today's agenda is packet drop latency switching issue. So what basically we check whenever any latency or packet drop issue came to us, we will check like any interface error is on the board or not, or any hardware internal errors. Then
Guys, am I audible?
Yes, bro.
Sorry, just okay. Okay, so what is then we have done the external over internal. So as we have the particular diagram, that is that one. So we just made the EBGP neighborship, so we are not able to check these parameters because of always when this parameter will check for the best selection criteria, whenever you will have the one side your IBGP neighborship and one side your EBGP neighborship. So once you will find it out the any EBGP neighborship, then you will be basically able to form the particular neighborship with that. Okay. Then we have IGP cost to reach next hop. Okay, what is that? If IGP configured background of BGP, then BGP can use IGP cost to reach next hop address. Lower cost will be preferred. See, but here is nothing any kind of IGP protocols working, such as OSPF, right, or EIGRP. Is it working? But might be, if suppose that if it is working that as well, but if I'm getting it as a, like, the EBGP neighbor, so the EBGP having the AD value that is 20, so OSPF having 110, 120, whatever it is, so it will prefer always always what, always it will prefer the lower AD value, right? So what is that? This is our the lower AD value, that is 20. But IGP cost to reach next hop, so it, whatever the cost we have, it will just select it as a OSPF, right? But here is nothing any kind of OSPF we are running it over here. Just only EBGP neighborship I just made it. So in this case, what we can do, it will not check basically this parameter as well. Okay. Now, then we have oldest path for EBGP neighbor only, right? If a router receive the same prefixes coming from the two different EBGP neighbors, then oldest path always be preferred. But there is one more condition: whatever the prefixes or the neighborship which is we made it from between the EBGP. So from the same time they are advertising their prefixes inside your BGP. There is nothing any kind of old route or oldest path which is we have, because of we are making connection, we are making connection just at the same time. Okay, so this will not prefer. Okay, then router ID of neighbor, so lower router ID will be preferred. Okay, lower router ID will be preferred. And if router ID is having the same prefixes coming from the two different IBGP neighbor, then lower router ID of the neighbor will always be preferred. But let's suppose that I have suppose that the router ID that is 1.1.1.1. I can manually, we can also configure the manual router ID on this as well, right? Suppose that, right? So if this one is getting the same prefixes which is coming from the same router ID, so what will happen? This will get confused. So this will also deny that. Then what will happen? Lower neighbor address, lower neighbor IP address. But if it is not getting this prefixes as a, like, behalf of your router IDs, so then it will what it will do, the lower neighbor address, neighbor IP address, so neighbor IP address cannot be same, router ID can be same, but the lower the neighbor IP address cannot be same. Did you remember? If we configure the same IP address, so what you will get, the some you will get some error, that is duplicate address mismatch error, right? So in this case, what it will do, whatever the lower IP address which is we have, suppose that 10.1.1.1, 1.2. Suppose that here we have 192.160.10.1, and here is 10.2. So it will make this one as a best path. Why? Because of this one, the neighbor IP address is having the lower IP address, then it will prefer this path for this case, right? See, we can manipulate anything according to us, but why we take this example, because of this will give you the some hint and where your all the kind of the path attributes comes inside of it, right? Like if you will take this kind of scenario, so then you will get realize that how exactly the BGP neighborship is going to form, and exactly how it is going to check it, all the kind of things, right? So in this case, your lowest neighbor IP address will be preferred, and then it will make it as a best one, because of on the both the side we are using EBGP and same router ID. What? Same router ID. Same router ID. We are using it, right? And whatever the prefixes, whatever the prefixes, I'm getting it. I'm getting it. Same prefixes inside the BGP, right? So in this case, the lower neighbor IP address will be preferred over here. Got my point? So this is the how you can manipulate your path inside your BGP. This is how you can manipulate your path. Got my point? Am I audible, guys?
Hello.
Yeah. Any doubt?
So, but it really reaches till this point to decide.
Yeah. Because of see, for the example, for the normal example, if I take it, suppose that. So what I can take, like we can take the four routers and we can configure the EBGP, IBGP neighbor between that, right? But what exactly we can do? If we have the same thing and the same neighbor, same next hop, okay, so in this case, like because of this is the rare cases, and this is this one, this case, you will like like where your all the kind of path attributes are going to check it inside of it. So we must have to aware with that kind of case as well. If we are getting this kind of things, so we must have to check the all the kind of the path attributes, like which path attribute is coming, and which path attributes we can check it after that, which path attribute we will check it after this case, after this case, like like then your how the path attributes are going to be work, how the your which path attributes which will work, like that. Okay, so this is how you can basically get identified, and you can utilize your path attributes according to our requirement.
The point 12 lower neighbor address. So this would be the interface IP, or like
Yes.
suppose we'll use the loopback
No,
IP.
lower interface, lower neighbor interface IP address. What is that? Lower neighbor interface IP address. Okay, lower neighbor interface IP address. Because of see what we do, like we run this command, right? Like router BGP 100, right? And we do the neighbor and the particular IP address of the neighbor, right? And then we do the remote AS. This is how you can form the neighborship, right? Or 200, whatever it is. So this is what this neighbor, this address is what, this is our neighbor IP address. When we form the EBGP neighborship, we have to give the neighbor IP address, right? So in this case, this this neighbor IP address is going to check it inside the last path attributes of that. Okay, I hope like, I know that this is a bit of tough to understand, but you must have to like aware with the all the kind of functions of your the path attributes. This will not clear in a one time. You must have to read at least 2 to 3 times for that. Then your problem will be solved, exactly how you can manipulate your paths for that. Okay, any doubt for this regarding the path attributes? Guys, say something. Do you have any doubt?
Also, hi. Okay, one thing also I would like to know what is BGP path prepared?
Path? What?
Path prepared.
See, path prepend is your like you cannot basically whenever you do this kind of things, yeah, path preferred or path prepend. Let me check it. Let me check it. Path prepend. Okay, this path prepend is what whenever you utilize these path attributes with your route map or access list, right? So where we have to what we have to deny the particular statement or deny we have to particular deny that particular IP addresses for that. And we do have one more thing as well, that is we call Bgp Black Hole, right? So you
Yeah,
this
it
yeah.
is. It is denying by the using the yes number.
Yeah.
Suppose
So
that you are receiving routes from the eBGP
mhm.
and you do not want to prefer what the BGP has selected the best path. So in that case, you do not want to set the traffic what BGP decided. You want to set the traffic goes through that link what you have as an administrator you have decided. So we use as a route map and add one different AS number into your
Yes.
path manipulation, and that is what sort of thing I understand.
See, the
Uh,
path prepend is what whenever you get the any kind of things which is coming from the same AS number, right? Using same AS number. Then in this case, what we can do, how you can utilize the things, that would be totally depend upon internal over external. Did you get that particular things? Let me just show you internal over external. That one is also going to check, and after that, if that is not happening because of we have to prefer the external prefixes for that in this case, right? So in this case what we can do, then we can go for what then we can go for the well known attributes. Okay, where your all the updates messages is going to check, and we can utilize using the local preference and next hop origin code, right? So we can utilize these things using this what using your well known path attributes, right? Because of this is this optional or transitive and non-transitive path attributes is made for the like external things like external path attributes, path manipulation. Okay.
yeah, actually we have done this in the case of we have two ISP, one from the BSNL, one from the Airtel, and since the particular route which is we do not want to get the traffic as the BGP decided is the
Mm.
best path. So what we have
Yes.
done, we have added one false yes number of that path,
Hmm.
uh, and after that we achieve what we wanted to do. We use the different path to go to the traffic.
Okay. So like you just manipulate the particular path using IBGP protocol, right? Because of you are doing the path manipulation using your well-known path attributes, right? So the well-known path
Right,
attribute
right.
will give you this kind of things to manipulate the path using the next hop criterias. Using your local preference, you can basically manipulate. You can increase the size of the local preference because of the higher local preference would be preferred, right? So this is how you can like manipulate the path using your local preference numbers, and then you can find it out the particular AS path, how much AS path we have between the particular areas, right? So we can just manipulate the particular things from there as well, like air path. AS path list can have maximum, like you can if you are using IBGP neighborship, so definitely it will just check the kind of whatever the AS path we have, right? Then you can just do some manipulating using your what using your local preference, because of the local preferences give you these kind of things for the IBGP, like the path manipulation of the IBGP. And you can just increase the weight as well, which is whatever the path you wanted to make it as a best, so you can increase the weight as well. Okay, you can decrease the weight, and
Yeah,
you
engineer,
can yeah.
can you show me that lab diagram? Lab. You see in the lab, in the router 12, you see the particular routes which you are receiving. So IP route. and there's a particular subnet that
Okay.
which we are receiving from the external AS or EBGP. Have you configured any such type of lab here?
Okay. See, what is happening? Let me tell you exactly. Suppose that here are the multiple prefixes which is we have, or let's suppose let it be this one. Uh, let's suppose this one having the lots of prefixes, and we have to reach where we have to reach on the internet service provider one, right? So here is our what? Here is our EBGP neighborship is working, right? And whatever the prefixes they will get inside this area, this is our what? This is route reflector, right? So the route reflector will handle all the kind of prefixes, and then it will just manipulate the best path. This will find it out the best path. So it will suppose that this will find it out the best path using your router number 14, right? If I'll show you router number 12 inactive, I think it's showing the inactive. This is inactivate as otherwise I will show you basically. So this router number 12 basically find it out, and this will just check the which one is the best path. Suppose that this router number 14 has a best path. So what it will do within this, because of the IGP protocol, IBGP protocol is working inside of it, inside of that, right? So what it can do, it can just manipulate the paths using your what? Using your local preference or med. You can use it, and you can utilize the best path using that as well. Otherwise, if you don't want to that, so what you can do, you can go for the what? Go for the IGP protocol as well. That is OSPF, right? Means you are getting the neighbors which is coming from the EBGP, right? And then you can prefer the IGP protocol that would be like OSPF or EIGRP, which is running over here for the internal purpose, right? And which path attributes will come inside that? Let me show you. Uh, Let me show you. Here is that. IGP cost to reach next hop. Okay, so IGP configuration, then you can use the IGP cost for that particular things, right? Means we have to check the particular who is the IGP protocols working inside that. So we can just manipulate the path using IGP protocol as well over here. Okay, or if you don't want to use IGP protocol, so let it be. You can use your basically local preference and made as well for the IBGP protocol, right? And then you can make it the any path has a best according to your requirement. Okay, you can increase the particular things on this particular interface for this kind of prefixes, which is we have the ID on that, right? And then it will make it as a best path using this. Got my point? Yeah.
Basically, this scenario works wherein we did not use any IGP, only the BGP is on the infrastructure.
See,
So
uh,
yeah, yeah.
yeah. See,
In IGP, we have lots of option to manipulate the path which we
yes.
wanted to send the traffic over the internet. But actually, in the case of there is no IGP, we are only running the BGP across the branches and DC infrastructure.
Yeah, so
So
that's
in
fine.
that
That's
case,
fine. If you are
mhm.
using the IGP protocol in that, so that's fine. Like then there is will be no problem, right? Means you can manipulate your path according to your what? According to your uh, the 12 path attributes, right? So whatever the path attributes you have for the IBGP for the selection based path, you can use it for that as well. Like you can go for the local preference, you can go for the med, right? You can go for the other path attributes as well. That would be like IGP cost to reach next hope and all, right? So you can basically check the all the kind of things from here as well, and then you can make it prefer just make the best path for that as well. Okay.
Right, right.
Okay, I think you don't have any doubt for that as well.
Actually,
Yeah.
it depends upon how much you are doing experiment with your
Yeah,
BGP
exactly,
into
exactly.
production environment.
Yes. And this
You
is
can learn
not
from
done
it.
enough. This path attributes is not done enough. You
Not
must have to
yes,
like
yes,
you
yes,
must
more than
have to
enough.
use the route map, prefix list, access list, right? Then then using that kind of things, then you can just make your path as a best, right? And you can deny the particular network. You can access the particular network using your what? Using your route map, access list, prefix list, right? So that one we will
Right,
also
right, right.
discuss. Okay, later on.
Yes. Okay.
Okay. So I think that is enough. Everyone don't have any doubt for that, I think.